Hi, this is Yupin Sun, an assistant professor in landscape horticulture with an emphasis on water conservation. I'm standing here today in a research plot at a CWEL research farm at the Utah Agricultural Experiment Station. As you may know, Utah is experiencing historic drought. Our governor declared a state of emergency due to drought and issued an executive order to ask water conservation in state facilities. We are a part of a large team led by the University of California in Davis with support from Specialty Crop Model State Program administered by USDA Agricultural Marketing Service.
My name is Paul Harris. I'm a technician for the Center for Water Efficient Landscaping, and part of my duties is to help facilitate the research projects here at the Greenville Research Farm. Early on into this project, we noticed a need for a deer fence. We saw that a lot of the ornamentals were being chewed on and eaten, and a lot of the drip was being trampled and broken. So it was quickly decided that we needed a deer fence to try to keep unwanted pests out. North Logan has a huge urban deer population, so it's something that's going to be an ongoing problem with us. This fence, it's nothing fancy. Basically what we did was we pounded a T-post in the ground about 1.5 feet and then put an 1.5 inch PVC pipe over the top of it and then put our plastic deer fence around, and it's secure with zip ties.
So the team also includes Oregon State University, the University of Washington, the University of Arizona. So the goal is to create an extensive Western regional landscape plant evaluation network that utilizes a standardized method to evaluate plant performance under deficit irrigation in 6 locations with different climate and different soil types. This is the first trial plot we established, and we planted 15 different landscape plant varieties that are newly developed by Dr. Ryan Contreras at Oregon State University, industry partners such as Spring Meadow Nursery, Star Roses. Plants are growing in the field for the first year. Actually, next year we are going to apply irrigation treatments based on the evapotranspiration. That is determined by a weather station in the farm, managed by Utah Climate Center. We will apply irrigation at 3 different levels: 80%, 50%, 20% reference evapotranspiration.
Hi, I'm JJ Chen, PhD student from Center for Water Efficiency Landscaping, and I'm introducing our sensor system in this plot. And in here, we install a Campo Scientific data logger system, and then this is powered using solar panel. We install sensor at 10 centimeter and 50 centimeter depths. So when we irrigate that, we can learn how water movement in the soil profile. Second, we can also learn the water content in the soil and then know how much available water for containing in our soil profile. And then every time we irrigate that, we can also calculate that how much water drainage and how much water evaporated using the soil moisture sensor we installed. Okay, so this is our plot. First, you can see we have a mulch on the surface of our plot. At the beginning, we layering 2 to 3 inches deep mulch to have 2 reasons. First, we want to limit the soil evaporation. Second, the mulch can also help us control weed efficiently. Besides, you can see right here, we have 3 funny pipes, and each plant will be assigned to one of the funny pipe and irrigate that. Each funny pipe represents 1 irrigation treatment, and then the plant was irrigate using the drip line right here. So next year, when we start our irrigation treatment, The plant will irrigate it using different percentage of ET, which is evapotranspiration rate. And then we can know and study the plant performance, and then we can understand their water requirement.
We will continuously monitor plant growth and development and collect physiological data, such as photosynthesis, stomata conductance, and chlorophyll fluorescence. We will also conduct open house to invite horticultural professionals and master gardeners to see the research plots here, see the plants here, and also help us do some evaluations. And hopefully we can select some drought resilience landscape plants for people in the green industry to use, to help water conservation and improve the environmental stewardship in the long run.